guys, in this video we are going to simulate a shear supported beam, and you can see that there are two reactions, one here and one here. They are shear reactions, so we will see that how they're gonna work in the ANSYS. And these are the dimensions: 47" and this 4" of height. And in this particular part of video, which is the part 1, we will be simulating it in the 2D type mode, in which we will give a thickness of about 0.1". So just go to the simulation right away. So go to static structural, double click here, go to geometry, right click here, and go to new design modular geometry. So it's opening. Okay, so you can see that this is the coordinate system over here. You can see it is in isometric view. First of all, we have to change the units into inch. Go to XY plane, and in order to perpendicular it, click here, go to sketching, make a rectangle, click here, and another click here, give a dimension. Okay, I'm making rectangle again. Just click here and second click here, Control Z. So now give a dimension of horizontal, click here, another click here, the third click here, one click here, another click here, and third click here. Go to vertical, give one click, second click, and third click, one click, second click, and third click. So you can see this is you can see the dimensions over here, 47" and 4". So this is 47", right? And in order to take it into the middle, so 47 divided by 2 is equals to 23.5. 23.5. Give it 4. Yes, this is 4. And in order to make it into the center, 4 divided by 2 equals to 2. So it is in the center, you can see. Now go into the modeling. Now what you have to do is select the sketch and extrude. Select sketch here, apply here, then click here, right click, generate. Now okay, one problem here, we don't want to make like that, so go extrude and click 0.1". Click there and then 0.1". Then you have to generate again, generate. So this is the beam. Now close it, go to model, double click here, I don't know why it is taking so much time. Okay, it's open. It's here. We have this thing. Go to mesh, right click, insert sizing, and go to sizing, select, click here, another click over here, because it will select the whole body. This will select a face, and this will select an edge, and this will select a vertex or a point. Now click here, another click here, apply. So you can change the mesh size by 2.5 or something, or even run the simulation on the default setting as well. So now right click over here and update. So it will make a mesh. So in order simulation, so we are going towards a coarse mesh. Right click over here, insert. As you can see that we have two reactions over here, so you can see that how we can incorporate that. Right click here, insert, and insert a displacement, and click here, zoom in. For this you have to press Control and then the scroller wheel. You can do like this, and if you release the control button and just press the scroller button, then you do like this. Okay, and if you want to, you don't have a mouse, then you can click here and you can now rotate like this, and if you want to click it, then click here, single select. Now you can click. Okay, and if you want to zoom in, click here, zoom, and okay. So if you want to zoom, just click here and go on the upper side, so you're zooming in, and click here and go down, so you're zooming out. So if you don't have a mouse, then you can also use ANSYS very well. I know that some of you people use ANSYS on the trackpad, through the trackpad of your laptop. So for that, it is also very easy. Just select it. Now you can select this, and if you want to rotate, click here. Now you can rotate. And if you have a mouse, then it is very easy, because mouse has scroller button, and you don't have to go there and there and there. Okay, I just do there. Scroller button se maine through scroller button I have zoomed out. Click here, you get the asymmetric view. So now we have to select the face. Click here and zoom in. So you can zoom in like this as well. So not like this, like this. So like this, you can also zoom in. Okay, so I think it's considerable. Select. Now select this, apply this, and give y0. Okay, now what you have to do, if you want to rotate, then rotate, no problem whatsoever, and click single select, and try to have this thing. Okay, now if you want to zoom in, just now you can zoom in very well as well, no problem whatsoever. Okay, so right click here, insert, displacement. First of all, single select, click here, apply y0. Now insert a pressure. We have to insert the pressure. Now I'm not doing that kind of stuff, I have to move very quickly. Now we have to give the pressure. So now I'm zooming out just like my traditional way, using mouse, and through mouse scroller button I'm zooming as well. Select this face, apply, go to normal, go to components, and give a pressure of about how much? About 85 psi. So 85 psi, but you have to give it in negative, because you need to make sure that it is going down. Okay, so you can see that y-axis is positive in the upper direction, so you have to apply on the bottom side, as you can see in this figure. So for that you have to put a negative sign. Now go to analysis setting. Okay, first of all I want to show you one thing. Give a insert stress, maximum principal stress. Okay, now I am running the simulation, and I know that it will not run. It will not run. I am telling you, and then I will show you that why it is not running. So as you can see, that is there is red color over here, which means that simulation has not completed. So for this you have to go to the analysis setting, go into weak springs, click here and turn it on. Now see the magic, it will run. Solve here. Now you can see that it has run successfully. So here's the maximum principal stress. Now I want to give a path. Insert, go to path. As we are defining path, go to insert, construction geometry, insert path, and in path you can minus 23.5 and plus 23.5, and as I have to go into the in the middle. If I want to go into the middle, then I will keep it. Okay, I keep this path. Now go to another constraint geometry, insert path, right, minus 23.5 just like the previous one, and we will make sure that it is in the bottom. So for this you have to put minus 2. Now 23.5, as you can see the origin is in the middle, so I am giving values 47 divided by 2 basically. 47, if you divide 47 by 2, then it comes 23.5. Now this is minus 2. You can make any kind of path through this, any kind of path. So okay, any kind of path you can make this from this. You can also rename them, like I give it like bottom. Okay, also you can do one more thing. You can also change pressure during the simulation. As you can see, the simulation has run. These are basically the boundary conditions, and this is known as in our language as called as the post processor. So in post processor you can get different results out of the simulation. Simulation has run successfully. After applying boundary conditions, simulation has run successfully. But if you, in order to get your desired results, you go into the post processor and define them in your way. So for getting the results, I'm making these paths out of it. um, but as I've told that simulation has run, so you can change the boundary condition also, like 85 psi, you can 85 psi, you can see that there is a little bit of change in the simulation also. So now you can see that the beam is bending outward, not inward. So just like that, I will go there and put a minus sign over here because I want to get the beam bending on that side. So now solve. So ANSYS gives you a lot of control in terms of simulation. Also you can change mesh size 1.25 like that, right? Now go right click here, solve. It will first of all make the mesh, then do the whole simulation on that particular mesh size. And also decreasing mesh size gives you accurate results that I'll show you in the mesh independency test as well. So this is the maximum principal stress. You can see that there are 4 boxes instead of 2. So this means that mesh has been refined. Now for our results, desired results, maximum principal, right? Go here, insert path, and give a path of bottom, right? And okay, bottom. Also insert and stress another stress, maximum principal same, but in this time you will get the path. Okay, here you can see this is bottom, and here you can see it is the path. Now right click here, insert strain, maximum principal, and give a path, middle path. Okay, now insert deformation and directional deformation in the y-axis. Change the y-axis and okay, and give the path which is the middle. Now for the factor of safety, right click here, insert go here, stress tool, and factor of 50. Now right click here and evaluate all results. Now everything is computed. You can see that the factor of safety is 4.1122, and okay, and directional deformation maximum is 2.99 exponent minus 0.035, and this is the maximum principal elastic strain, maximum principal stress, maximum principal stress 2. So in the middle you can see that there are lesser stresses, and in the bottom you can see that there are more stresses. Obviously, you can by the diagram you can see that in the bottom there is more deformation as compared to in the middle, and you can see that the maximum is also in the bottom. So you can see maximum is 881 of 8818.5, and in the bottom there is 88,815 18.5. So you can also see that there are points. So at 23.5, this is the maximum. Okay. Now we are going towards the mesh dependency test of the simulation. So for the mesh dependency test, what you have to do, you have to click here, a little p appears, p for parameter, and for this I am taking this one. Click maximum principal stress 2 and the p. Okay, now close it. Here appears the parameter set. Double click here. Now there, now what you have to do is you can put up multiple sizes of mesh. Instead of doing it all manually, just give all the numbers, right? Like 1, 0.9, 0.8, 0.7, 0.6, 0.5. And now ANSYS will do this simulation again and again on every single point and give you result. This process takes time, so click update all design points. Also you can select these points, then right click, then it will say you that selected design update selected design points. You can do that as well. So now it will take a little bit of time. I will refresh myself, then we'll meet. So you can see that as we have done with the mesh dependency test, now you can particularly see that this 1.25 inch of mesh size was very good, because all the results were moving around there. So we have achieved the mesh dependency at 1.25 inch. Now let me show you if you want to calculate 1 point. Let's say like I put 2.5. Now click here. If I want to update it, right click here and update selected design point. Now it is updating. Let it update. So it has finally been updated, and you can see that at 2.5 it is 8,798.7. So 8,818 and 8,700, you can say it is 8,800. So it has an 18 psi of difference, which means that this difference is large as compared to all the design points. So if you want to make a graph of it, then I would suggest you that you go like 2.4 and 2.3 and 2.2 something, right? Then update these design points. You can select it like Control Shift and down arrow key. Right click here and update that selected design point. Click there. I'm not clicking it because I have to close this session. I hope that it would be very helpful for you. Bye bye.